diagram, let me jump around here. For each transfer of energy through a power plant, so we're talking a nuclear power plant, and we are up at the top here. So our first example is with uranium. Every time that we change uranium into another form of energy, so here we've got to mine the uranium to get it to the power plant, to then convert it to actual electricity. Every step of that process, we are actually losing a little bit of energy. It's just like our food web, how we had the 10% rule where we're losing 10% each time. This isn't exactly 10%, but you can see that the rule vaguely applies here, that we are losing some energy in the form of heat. But when you compare that to sunlight and solar power, so our second example here, you can see that when you have solar panels working outside for you and they transmit that energy to your house for use, there's really only one change that energy has to undergo, and so you're losing some energy. It's not 100% efficient, but it's pretty darn close. And that's thanks to our second law of thermodynamics. For comparison, because this is a commonly missed question on the Moodle prior knowledge quiz, incandescent light bulbs are one of the most inefficient forms of like machines or appliances that we have out there. It's not too far ahead, though, of the internal combustion engine. And if you aren't sure what that is, that's just the engine inside your car, as long as you're driving a car that runs solely on gasoline, which is the more common car to drive right now. So it is kind of interesting to look at how much we actually can get from like an incandescent light bulb. It's so inefficient. So most people have begun to install like fluorescent light bulbs into their house, or using lower lighting, having like a dimmer. And if we come back to this diagram, we think of nuclear versus solar power transfers. One solution is to take the waste heat here produced along the way and to try and use this. So this is another way to actually improve our efficiency. And that's referred to as combined heat and power systems, where you're taking the heat that's lost through the energy transfer process and you're going to filter it to another like nearby company that could use it for heat. So they are actually able to use some of it, but that takes obviously more complex systems. Efficiency for vehicles, when we talk about cars, is really low. So the efficiency of our gas-powered cars is well below 50%. And one of the things our government did in the 70s was they came up with these CAFE standards, which regulate your fuel economy. So when you go to buy a car, one of the things you look at is obviously the price tag. Normally one of the second or third items you're going to look at is maybe size, and then fuel economy. How many miles per gallon can I drive my car for? And I know as a first-time car buyer, that was one of the things that I was really concerned with. So between the 70s and the 80s, we actually saw a huge jump, and this next graph here does a really nice job of showing you that from 75, so right around here, to about the 90s, you see this huge jump in fuel economy. So cars are becoming more efficient. And then for some reason, it levels off here, so for the next 10 years, and then you actually see this slight drop. And that slight drop is about a 6% drop, and that's thanks to our SUVs. One of the reasons, though, people drive gasoline-powered cars despite their inefficiency of fuel use is the cost. So cost is cheaper for a lot of these cars, and the gas prices are cheap. So they're actually artificially cheap, even though we seem to, our news seems to focus on the rising gas prices over the summertime and how it's going to affect your summer travel. In actuality, these are really small fluctuations, and That's because gasoline is actually estimated, if we were paying for all of the hidden costs, at about $11 a gallon. And that's that's a really high number. I can't imagine going to the gas station, the pump, and fueling up for $11 a gallon. That would probably break your bank. So there's a lot of ways that the government has been able to keep it affordable for consumers, and that's with subsidies. They also help out the oil companies with different tax breaks. So those are just a few of the ways that they're able to keep the costs really low. And that's really similar to how the cost of even like coal is produced and how there's hidden costs there too.